In this lesson, we're going to talk about how to solve equations, and we're going to be justifying each of our steps using the properties of algebra. First, let's talk about the steps for solving equations. There are 5 steps here. Remember that you need to copy these into your notes, and you can pause the video at any time. So the first step is to eliminate grouping symbols and fractions, grouping symbols being parentheses or brackets. The second step is to combine your like terms on each side of the equation. Step 3, move all variables to one side, either using addition or subtraction, depending on what the sign of your variable is. Fourth step, move all constants to the opposite side, using either addition or subtraction. The fifth step is to multiply both sides by the reciprocal of the coefficient of the variable. Again, if you need to pause this video or rewind, you may do so. Alright, let's jump into it. The first equation that we're going to work with is 1 plus 5x minus 6x. For this equation, remember, we're not just going to solve it. We're going to justify our steps using the properties. So step 1 was to get rid of the parentheses. And there are no parentheses and there are no fractions. So we need to combine our like terms. So if you'll see here, 5x and the 6x are like terms. So if I combine these, 1 plus, I've got positive 5x minus 6x. Well, 5 minus 6 is negative 1, so it'd be minus 1x, or just minus x. So to go from here to here, we combined our like terms, which I'm going to abbreviate CLT. Next, we need to move all the variables to one side. All the variables are on the left, so we're good there. Next step, move all the constants to the other side. 1 and 0 are the constants. So they need to be on the opposite side of our variable. So the 1 needs to be moved over here, and I do that either using addition or subtraction. I'm trying to make this become a 0 pair, so I would say 1 minus 1, because I know that is 0. When I do that, 1 minus 1 gives me 0. I'm left with minus x equals, and I know that 0 minus 1 is negative 1. So what property says that we can subtract 1 on each side? Well, actually, it would be the addition property of equality, which I'm just going to abbreviate. But that says addition, and we've done subtraction. Remember that subtracting a number is the same as adding its opposite. So subtracting 1 is the same as adding negative 1. So I'm still using the addition property of equality. All right, next step. 0 minus x. Remember, that's the same as 0 plus negative x. Well, 0 plus anything is anything, so that leaves me with negative x equals, and then negative 1, you can just bring that down. So, how did I get to this step from this step? Well, first off, 1 plus negative 1 gave me 0. So that tells me that I'm using the additive inverse property for that one. And then to go from this step to this step, 0 plus anything is anything. That is the additive identity property. All right, last step is to multiply both sides by the reciprocal of the coefficient of your variable. So your variable is negative x. Its coefficient, negative x, is the same as negative 1x. So if I multiply by the reciprocal of the coefficient, so I need to multiply both sides by the reciprocal of negative 1, which is negative 1 over 1. Negative 1 over 1. How do I know that I can multiply both sides by negative 1 over 1? How do I know that that's okay? That's the multiplicative or multiplication property of equality there. Now, when I do that, that's going to leave me negative 1 over 1 times negative 1 gives me 1x, and I'm left with equals negative 1 over 1 times negative 1 is equal to 1. All right, how did I go from this to this? Well, negative 1 over 1 times negative 1 gives me 1. I know that by the multiplicative inverse property. All right, and finally, 1 times anything is anything. So 1 times x is x. And I know that because of the multiplicative identity property. So the final answer is x equals 1. All right, let's try this problem. All right, eliminate grouping symbols and fractions is our first step. We don't have grouping symbols, but we do have fractions. Now, we can eliminate fractions by multiplying by the denominator. But remember, according to the multiplication property of equality, you have to do whatever you do on one side, you must do on the other so that things remain balanced. So I can do this because of the multiplication property of equality. Okay? When I do that, 7 times negative 2/7 x leaves me with negative 2x, then plus 42. 7 times 4x is 28x. 7 times 3x is 21x. Okay? Next step is to combine like terms on each side. No like terms here, but there are like terms on this side. So I'm going to bring everything down. 28x plus 21x leaves me with 49x. And I'm just going to write CLT. I combined like terms to get to that step. All right, next is to move all the variables on one side. Now you have variables on opposite sides here. So my suggestion to you, since 49x is already on the right, I would move the 2x over here on the right. Now, in order for me to do that, I can add 2x on both sides. That's going to result in 0 here. Bring down the plus and the 42 equals, and then if I do 49x plus 2x, I get 51x. So let's back up. How did I know I could add 2x on both sides? How do I know that that's okay? That is the addition property of equality. All right, and then I ended up with the 0 here. How did that happen? Because of the additive inverse property. A number plus its opposite is 0. Okay? So if I simplify over here, 0 plus 42, that's just 42, we know. What property tells me that? That would be the additive identity property. 0 plus anything is the other number. All right, fifth step is to multiply both sides of the equation by the reciprocal of the coefficient of x. The coefficient of x is 51, so I need to multiply both sides by 1 over 51. How do I know it's okay to do that? Because of the multiplication property of equality. All right, when I do that, I end up with 42 over 51. And 1 over 51 times 51 is 1, so that's 1x. How do I know that? Because I'm using the multiplication or multiplicative inverse property. A number times its reciprocal is 1. Okay, 1 times x I know is just x. So let's actually move that down a smidge. 1 times x is just x. So, and I know that because of the multiplicative identity property. All right, and you are done here, except for this can be simplified. We can divide both 42 and 51 are both divisible by 3. So you end up with 14/17. That should be your final answer. All right, next equation. Step 1 is to eliminate grouping symbols and fractions, and in this case you do have grouping symbols. We use the distributive property to get rid of those grouping symbols. Outside of these sets of parentheses, I have a negative sign. That is understood as -1. Okay? So I'm going to use my distributive property here. So I'm going to say -1 times 1 is -1. Think of it as -1 times positive 4x. That gives me minus or negative 4x plus 4x equals -1. So to go from this step to this step, I used the distributive property. All right, step 2 is to combine like terms on each side. If you'll notice on this side I do have like terms, -4x plus 4x. Well, that's actually a 0 pair. They cancel each other out. So that's the same as -1 plus 0. and then I have equals negative 1. To go from this step to this step, I simply combined my like terms. Now, negative 1 plus 0 is just negative 1. Looks like we might have a problem here. But how did I go from this step to this step? I used the additive identity property. Now, you notice that we have no x here. We have no variables. Our variables have canceled out. If your variables cancel out, two things can happen. You can either end up with a true statement or a false statement. In this case, negative 1 does, in fact, equal negative 1. So we end up with a true statement. If you end up with a true statement, that's saying whatever value you plug in or substitute in for x, you will get, it'll work. Any number will work for x. So for example, if I put a 2 in place of x and solve this side, it would equal negative 1. So the final answer we want to write here is our solution is all real numbers. Well, since there are an infinite number of numbers, another way to say it is there are an infinite number of answers, but all real numbers. So if you end up with a true, if your variables cancel out and you end with a true statement, the answer is, or solution set is all real numbers. All right, let's try a fourth problem. Let's get rid of the grouping symbols first, and we do that using our distributive property. 11 times 7 is 77. That'd be minus 121n. And I can use the distributive property over here as well. So that's negative 132n minus 44. Again, I'm going to justify my step. How did I go from line 1 to line 2? I use the distributive property. All right, combine your like terms on each side. There are no like terms on each side. So next step is to get all our variables on one side. Now, you have variables on both sides, and you can either move the negative 132n over here to the left or the negative 121n to the right. I'm going to choose to move the 121n. Now, since this is a subtraction statement, you can think of it as you want to do the inverse. That's one way to think about it. Another way to think about this is if you did keep, change, change, you can think of that as negative 121n. So if you add 121n, you end up with a 0 pair, which is what you want to do. If you add it to one side, you have to do it to the other, which we know by the addition property of equality, which we'll abbreviate. So here you're left with 77. These made a 0 pair, so I'm just going to put plus 0 equals. Now negative 132n plus 121n. That gives me negative 11n and bring down the minus 44. So from this line to this line, I had a 0 pair. How did I know that that was going to be 0? Because of the additive inverse property. I took a number and its opposite and I was adding them together. All right, well, 77 plus 0 is just 77. How do I know that? Because of the additive identity property. All right, so all my variables are on the right, so the constants need to be on the opposite side, which would be the left. 77 is already on the left, so the 44 is the number that we're going to be moving. So do I add it or subtract it? Well, remember that minus 44 is the same as plus negative 44, so yes, you do want to add 44 on both sides here. All right, when you do that, 77 plus 44, let's see, that'd be 11, so that's 121. Here you're left with negative 11n, and that'd be plus 0. Oh, we forgot to justify this step. How do we know we can add 44 to both sides? Because, again, that addition property of equality. And how did we know we got a 0? Because of the additive inverse, because that made a 0 pair. All right, let's simplify again. Negative 11n plus 0 is just negative 11n. We know that because of the additive identity property. All right, now we're ready for step 5. We want to multiply by the reciprocal of the coefficient of your variable. That's a mouthful. There's your variable. Its coefficient is negative 11. So we want to multiply both sides by negative 11. Oh, I'm sorry, by the reciprocal of negative 11, which is negative 1/11. And I'm going to write that down here. We're now doing the multiplication property of equality because I'm multiplying both sides by the same number. Now, when I say negative 1/11 times 121, I'm going to end up with negative 11. And if I say negative 1/11 times negative 11, well, that's going to, actually, let me move this down one step. Sorry. That's going to end up being 1n. Negative 1/11 times negative 11. I know that because of the multiplicative inverse property. A number of times its reciprocal is 1. All right, and then 1 times n is just n. I know that because of the multiplicative identity property. So I have that n is equal to negative 11. And I've justified each step. All right, let's do this next example. All right, step 1, let me move this out of the way. Step 1 is to get rid of your grouping symbols. There are no fractions. So over here on the left side, I'm just going to bring all of that down. And I'm going to get rid of my grouping symbols by using my distributive property. So that'd be 7m plus 7. Now, be very careful here. There's a minus here before your distribution. So let's do the keep, change rule here. So think of this as plus, now negative 7 times m is negative 7m. And then you're doing, so this might be confusing again because you've got a negative 7 out here. So let's do keep, change again. That's better. Negative 7 times, or plus, bring down that plus sign, negative 7 times negative 12. That's going to be a positive 84. All right. So we got rid of our grouping symbols. Now we need to combine our like terms on each side. Oh, justify your step. We use the distributive property. Okay. On this side, negative 2m plus 2m is 0. Over here on this side, let's see, I've got 7m plus negative 7m, so that's 0. And then I've got 7 plus 84. Those are like terms. So 7 plus 84, what's that? 91. So I got from this step to this step by combining my like terms. And then over here, 0 plus 91 is 91. Now I got from this line to this line by using my additive identity property. And we have a problem here. This is similar to the previous problem that we did in that the variables have canceled out. But I have a statement, 0 equals 91. Well, you know that 0 does not equal 91. That's actually a false statement. Now, we know if it had been a true statement, we would say that the solution is all real numbers. But it's not a true statement. So the solution said it's not all real numbers. In this case, it doesn't matter what value we substitute in place of m. Nothing will work. We will always end up with 0 equals 91, and that's false. So there's actually no solution here. When you are solving equations, there are 3 different possibilities for your solutions. You can have one solution, which is what you're used to finding. You can have all real numbers, and you can have no solution. Those 2 options are possible if your variables cancel out. Did you get a true statement? Then it's all real numbers. Did you get a false statement? Then we say no solution. Be careful with that. All right, on your own, I want you to try these problems. There are 5 here. You need to remember to justify each one of your steps and be prepared to discuss your work in class tomorrow. Good luck.